And welcome back. Yes, today we're going to be talking about debugging your ESP32 using PlatformIO running on Visual Studio Code. If making a PCB is a bit of a puzzle to you, let JLCPCB help you put all the pieces in the right place. EasyEDA is an intuitive electronic design tool, just as I'm showing you here. And when you've done that, you can convert it into a PCB like this one here. And you can view it in 3D and see exactly how it's going to look before you order it. It's easy to order from JLCPCB directly from within EasyEDA, with fast, reliable deliveries, and now $2 for 5 pieces, including aluminium boards. They can even assemble them for you at no extra charge. Why don't you see what JLCPCB can offer you today? Yes, indeed. Now, yeah, what's that? You're not using Visual Studio Code and PlatformIO. Well, I'm afraid I've got some bad news for you. Arduino, that is Arduino IDE 2.0 point something, says no, I'm not going to debug an ESP32. It will debug some of the Arduino boards, but well, frankly, nobody uses the ones that it can debug. Let's look here. So this is the official Arduino documentation. It says, okay, debugging with Arduino IDE 2.0. Oh yeah, it doesn't work with the 1.8 at all. But anyway, 2.0, it goes, yeah, we got this wonderful new debugger. So you really should use it. And it goes, these are all the boards that it works with. You think, just a minute. I don't think I've got any of these boards. Now, obviously, it's never ever going to work with an Arduino Uno or something like that. It just hasn't got the hardware built into it, nor has it got the capability, the space, the memory, whatever, to ever run any kind of debugger. We accept that. But that's all the Arduino IDE is currently supporting. Now, there's one on here that caught my eye. I thought, the 0. Now, I've got a 0 somewhere. I'm not sure where it is, but anyway, I had a 0 and I did some debugging with it 18 months ago, and it was so flaky. I think I showed you briefly, and I said we'll come back to that in a future video. Well, I guess this is the future video 18 months later. Let's just have a look at the 0 there and have a look what sort of board it is. Oh, there it is. What? 38.90 €. You got to be kidding me. That's about, well, it's about the equivalent in dollars, $38 for that. And I think, I don't think people are going to spend that sort of money just so that they can debug their code. No, I think Serial.print statements are more likely to stay than anybody getting one of those. Well, there is talk on the internet about maybe Arduino, the company, Arduino.cc in other words, they may bring ESP32s into the debugging fold as far as the Arduino IDE is concerned. But given that the Arduino IDE is really primarily aimed at Arduino boards, don't hold your breath. And in the meantime, we can use PlatformIO running on Visual Studio Code. So yeah, if you're not running on it yet, I would strongly recommend that you go to the PlatformIO download page and download it and, well, get it running, because it's a huge step up even from the Arduino IDE 2.0. So out of all those bits of hardware then, what do you actually need just to get started with debugging? Well, the first thing you need is one of these, the ESP-PROG. It's pretty cheap, something like $12. You can pay more. I mean, I bought 2 thinking they're going to be different, but they're not. $12, $18, plus a bit of shipping and tax if you live in the UK. But they're all much of a muchness, and I think they all conform to the Espressif design. So yeah, that's what you need. There we are. There it is on screen to say where I bought mine from, and yeah, they're all much of a muchness. And they come with these little cables, so you might well think about getting some 2.54 cables as well, or at least one. Watch the voltage jumper on here. The voltage jumper on both sides, but we're only using this one JTAG side, not the serial side at the moment. It's 5 volts one side, 3 volts the other. That's actually set to 5 volts at the moment because my board, this one here, uses only 5 volts as it goes into the 5 volt pin. But you might want to use the 3 volt or power it yourself from a USB, especially if you're using Wi-Fi, of course, because that does suck the power out, doesn't it, a little bit. Right, everything's connected up on the workbench. We have the ESP-PROG here connected via the 1.27, that's the little tiny cable, down to this little adapter thing, a few DuPont cables back to the TTGO V1.71, one of the boards that works very nicely. So let's have a look now what happens. We'll just leave that as is. What happens in the actual code window. This is now Visual Studio Code and PlatformIO. Okay, let's have a look at that. Now, I've just been editing this video and I've chopped out about 20 minutes of waffle. I say waffle, it was technical information about how to set up the board and download drivers. Very simple to do and all that, but it takes time. So what I'm actually going to do is link in to pages like this, right? All the details are in the video description and in my GitHub. So you'll see pages like this one and this one, all about the ESP-PROG and the driver substitution that you have to do on that ESP-PROG piece of hardware. Takes about 5 seconds once you've downloaded this actual utility. You've got another one here, how to use the ESP32 debugger. There's all sorts of things going on there, right? And I'm thinking, what's the point of me regurgitating all that when you can just go away and read it? You've got to read it line by line anyway if you're going to start installing drivers, right? So I'm going to cut all that bit out. That's on the cutting room floor now. And I'll leave you with a whole series of links down in the video description that you can just read at your leisure. But the rest of the video is definitely worth watching. Okay. Just thought I'd sneak this bit in quick. So this is a very simple blink program. The blinking effect is done with a little function that I've written so we can see what happens, how we can get into that function. But apart from that, it's pretty standard. So what we need to do is make sure you've pressed this icon here to get into the debug bit. There we are, that one there. And then say, well, it's waiting now to say, well, what sort of debugging do you want to do? We can either do it with the uploading or skipping the pre-bug. I don't quite know what that middle one does actually, but this one here, the bottom one, says, look, I've already uploaded the code. I don't need to upload it again. So let's just get on with the debugging, which is what we're going to do just to speed things up. Otherwise it takes a little bit of time. Okay, so we're going to click that one and now I'm going to press F5. And with any luck, it will stop at the very first statement within setup. So F5, you can see there's lots of messages on the debug console. A lot of them in red, which does not mean an error necessarily. Okay, because look, a lot of them are info messages. It certainly doesn't mean an error. It's fairly slow, the debugging overall, because it's got a lot of work to do. There we are, and it's stopped now by that little yellow triangle arrow thing up there to say, yeah, right, I've stopped here. Now what? Now we can set some breakpoints by clicking in this margin here and saying, well, I want a breakpoint here on counter ++. All right, just to see what happens. Now you can either press F5, which means continue running until you hit that breakpoint, or F10, which means just do that statement you're on and then move to the next line, wherever that is, or F11, which means go into the function that's being called and we'll, work your way through the code that way. I'm certainly not going to do that on pin mode, because pin mode is a function written by Espressif and it goes into all sorts of deep code and assembler eventually. So we'll just say run F5 and it should come back down to here. Here we are. Now counter is 10 because it shows you what we can watch here. I've clicked the plus button that says I want to watch counter because there's something wrong with counter, for example. Okay, well, okay, so it should increment it by 1. If I now press F10 just to go to the next line, F10, it's gone to the next line, and counter, as you can see there, it's gone to 11. Woohoo, great. And at this point, everything's stopped. Core 0 stopped, core 1 is stopped, it's just paused. Now, I'm not quite sure what that means for like Wi-Fi and Bluetooth and stuff like that if you've got those switched on whilst you're doing this debugging. Obviously, Wi-Fi can't just suddenly stop, as far as I know. I don't know. We'll have to experiment a bit more with this in future videos, perhaps. Anyway, now I'm just going to show you one thing off. We're going to take that one off there and put it on here. You can have multiple breakpoints, but don't go mad because I've read lots and lots of things on the internet and it says if you have too many breakpoints it gets confused and refuses to do anything ever again. So we're going to press F5 and it will run until the next breakpoint, which is on this blink LED function. So F5, there we are, so it's now down here. Now if I were to press F5 again, it would just run until it reached the same breakpoint the next time round. But we want to say go into this function because maybe we're trying to debug something within this function. For that we do F11. So F11, and there we are, the first statement of blink LED, which basically just reads the state of the pin and switches it on if it's off and off if it's on. Okay, simple as that, and then delays for a second over here. Fine. Nothing special happening here. If we look at the actual board at the moment, so here we are, you can probably just make out that green LED is on at the minute, so we'd expect that to go off, would we not, if I press F5. So F5, so it should have gone through that bit of code. Let's go back to the code window. Oh, hasn't gone off yet. What's it doing? Oh no, we're still there. That's because my cursor focus has moved because I changed windows. Right, F5 and go back to the main board, and there it is. It's now gone off. Right, so we can see it is actually doing something. Well, doing what it's supposed to do. Right, back to code, and it's gone back to blink LED. Now at this point, as I say, if you don't press F11 to go into, you can press F10, which will just go to the next statement. Let me put the cursor back where it should be, over here. Right, F10. And it's the next statement, and so on. And F10, next statement, and so on. F5 will just run until the next breakpoint, which is wherever we are. Great. So that's basically it. You've got F5, which just means continue until the next breakpoint. F10, which means single step. F11, which means dive into the function that you're currently on. Shift F11 means step out of the function you're currently on. And yeah, that's basically about it. I mean, there's not a lot to it in that sense. It is a little bit, well, slow. As you saw how long it takes to get to the next breakpoint. If I press F5 now, and there we are. See, that took what? Nearly a second, half a second, where in reality that'd take about, a millisecond, wouldn't it? So you have to be a little bit patient with it. But apart from that, it's all working great, and you can look at all these variables here. Look, if I hover over counter, you see that 13 popped up there. You see that 13? Because that's what the value of it is. You can also see it over here in the watch window. And, well, that's about it, really. Once you've got it working like this, you can delve into the bit of code you think is not working. Why does this funny formula that you've written not come up with the magic answer of 42? Yeah, this is the debugging method for you. Okay, I think as a sort of an intro in what you can do there, it's enough, because anything else you can delve on the internet, and I'm sure you'll find other examples of what you can and can't do. But as a simple debugging step by step, this works very well. And I've spent probably 20 years of my life on big systems like .NET, Microsoft .NET, C#, where we spent all our life in debugging mode, wondering why our code didn't do exactly what we wanted. Obviously the programs were quite complex, and I don't think we would ever have debugged it without having this facility. So it's an absolute godsend, and miles better than doing lots of Serial.print type statements, believe me. Okay, the debugging system as a whole works very well when it works. Some boards it just does not want to play with at all, and it throws all its toys out the pram, and you can just spend hours don't ask me how I know this, but you can spend hours on the internet trying to figure out why some boards work and some boards don't. Now, I don't know the reason why they don't work, but I have established some sort of pattern, and I'm actually having a different board delivered today just to tell me whether or not my theory is correct or not. But in the meantime, I can show you that I had this board created by JLCPCB for the DevKit 4 ESP32, which is very common. This is the 38-pin version. We'll have a chat about the 38 pin and the 30 pin in a future video, but I've got lots and lots of these boards, so I thought, well, a board like this where I can just put the ESP32 on and use one of the JTAG sockets at the top there would be absolutely ideal. So here is one where I've populated it. Yeah, so I've got my ESP32 on there, just plugs in, and of course you can take the thing out again. There we are. So it's very simple, hardly any components on there at all, just a resistor and a capacitor and an LED over there to show you if you want to see something blinking, a bit like that one down there, which incidentally I've just noticed is stuck in debug mode. If you notice, we never actually finished that session, so it's still waiting for me. So let me just clear that. I'm going to say stop debugging, and that LED should start blinking. And well, it went off. Okay, we'll just quietly forget about that for the time being. I don't know what's going on. Right, so this is the board then that I created, and on the back I've just got a few bits of information on it. I'll put the design for this board up in my GitHub, so if you want to either copy this or indeed adapt it for a different type of board, you can do that. And in fact, my idea for this came from this one here. Now this one here was created by Brian Lough. There he is. He was in Ireland, and he had two boards. This one here for the Mini 32, of which I had one, so I thought, oh, well, I'll try that out. And I think he had another one for another type of board that I haven't got. I think it might have been a feather or something like that. But this one works very well. The only downside to this board, apart from using this type of actual module, is that you can't connect any peripherals to it. Once you've got your actual device in there, which would help if I got it the right way around, that way. So you plug that in, that's fine. Put your JTAG cable in at the top. You see the big cable, they would match up. Yeah, so a simple cable between the two would be fine. But the trouble with this is that you cannot connect any further peripherals to this once this is correctly inserted. So when that's like that, you can't connect anything else up to it. So if you've got a problem with one of your peripherals that's causing issues in the code, it'll be difficult to debug, which is why I created this one, so that you can have an extra row of pins or something down the side to connect up any peripherals you want. So that's probably in brief where I've got to so far. When the other board turns up later on today, I'll continue recording if my theory holds true. Who knows? We'll wait and find out. Okay, I've tested out many more boards now. As you can see, there's quite a variety here, and not all boards work. What I can say is that out of all the boards I've got here, all the ones with these sort of pre-built Espressif modules with the actual device inside, they do not work, which is unfortunate because I've got loads and loads and loads of them. All the ones that I've tested, like this one here with the X on it, with the bare sort of chip and then the other bit all just built round it, exactly the same you would think as what's under one of these. If you delid one of these, it's pretty much the same underneath, but these work, these don't, and I've absolutely no idea why. But I mean, it's not the end of the world. They might fix it. In fact, I might raise a bug to say, why doesn't it work? And why do these other ones work? But even if your ESP32 is not supported using JTAG, you could, of course, get one of these specifically, couldn't you, that you know does work, upload your code on that, find out what's wrong, and then put it back into the module format of your choice, because at the end of the day, the ESP32 underlying all this is exactly the same. Okay, I think we'll leave this little intermission as it is. I can't say which boards work and which boards don't. Of the ones that I've found that do work, I'll put a list underneath, but it's a very short list because I don't have that many boards, and there's dozens and dozens and dozens out there. Well, I hope that's whetted your appetite, if nothing else. you've got to use Visual Studio Code with PlatformIO on top, and you can debug some of those ESP32 boards. And there are probably many others out there that work as well. Who knows? But it really is a case of, chalk and cheese really when using Serial.print statements to find out what's wrong versus actually line-by-line debugging of the bit of code that you think is suspect. Makes a huge difference. There's nothing to add, nothing to remove afterwards. It's just works. It's really good. It's a pity about some of those boards not deciding to play nice. Who knows why? Perhaps they'll be fixed in a future release. Who knows? Anyway, if you've got any comments about how you debug stuff, please put your comments down below. I love hearing from you and I reply to them all. And if you liked this and found it moderately entertaining, or perhaps I should say edutaining, yeah, give me a like up there. That's it, up there, because I like the
hey,
yay, that's the one. Yes, very good. And if you like these sort of videos, generally talking about Arduino and ESP32s and all sorts of things like that, don't forget, subscribe and tick the bell. You gotta tick that bell, as you won't hear from me ever again. That'd be disaster. Okay, and I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.